Good morning, ladies and gentlemen. This is Mr. Nowinski. Even though I'm not here, my voice is still here, and you're watching this video. Hopefully your substitute's already taken attendance, and you guys have exchanged your papers. Ideally, what you're going to do is put a star next to the ones that are right, and then write the correct answers in for anything that's wrong. Again, we're going to try to hand back these papers for you so that you guys can actually have these so that you can use them to study again for your test, which is tomorrow. We're going to get started. Again, you've exchanged your papers, so here we go. Let's get started. The first one is 10 times the square root of 2. If they got it right, put a star next to it. Otherwise, write in the correct answer. Number 2 is 5 times the square root of 3. Number 3 is negative 5 times the square root of 5. Number 4 is 2 times the square root of 7. Number 5 is 4 times the square root of 6. Number 6 is negative 4 times the square root of 11. These next few required a little bit more work. I did not show the work, but if you need to go back to our notes or anything else, you can see similar work. Number 7 is negative 2 times the square root of 3. Number 8 is 5 times the square root of 6. And number 9 turns out to be 14 times the square root of 2. Number 10, again, a lot of work for some of these. It just turns out to be negative square root of 10. Number 11 is 45 times the square root of 2. And number 12 is 7 times the square root of 7. Number 13, when you simplify these things, you'll notice the radicands are 6 and 5. You cannot combine those. So it would just be 15 times the square root of 6 and 2 times the square root of 5. Number 14 is negative 17 times the square root of 2. And 15 is 12 times the square root of 6. These last two at the bottom, let me move this out of the way for us, should be negative 1 plus 13 times the square root of 3. I do want this to be in this order. I do want the negative 1 to be first and the 13 square root of 13 to be next. They do need to be in that order or else they're going to be wrong. Remember, we always write the constant or the whole number over here by itself, and the radical part of it we write last. Number 17, when you do this, the radical part of it actually drops out, so we just have an answer of 10. At this point, please put the correct number at the top. Why don't you pass them forward, pass them towards the center, and your substitute will collect them. She'll also hit pause for a minute as we collect things and pass out your review sheet. Here we are. We're looking at our review sheets. Hopefully you guys each have your review sheet. Hopefully you guys have it. Hopefully you've gotten it. Hopefully you've put your name and the correct date and everything on it. What I want you guys to do is to follow along and make sure that you guys are doing all the work as I'm doing it. Again, this is a great review for you for your test, which is tomorrow. First thing we do is we break up 75 into 5 and 15. 15 can then be 5 and 3. We look to see if there's any pairs. There are a pair of 5s. So we just say this is 5 times the square root of 3. Again, there's several different ways you can break these up. I'm just going to try doing these whichever way comes to my top of my head as I'm doing these. You might use different numbers, but in the end, you should always get the same answer, 5 square root of 3. To use a perfect square, we could say this is 9 and 6. 9 breaks down into 3 and 3. 6 is 3 and 2. We ask if there's any pairs. There are a pair of 3s. That means it can come out. Anything left over has to go on the inside, so that'd be this lonely 3 here and this lonely 2 here. At the very end, we say that's 3 times the square root of 6. Remember, whatever's on the inside gets multiplied together. If there's more than one thing on the outside, it's also multiplied together as well. Number 3, we break down 80 into 16 and 5. 16 is 4 and 4. You notice if it's a perfect square, you could stop there. If you didn't, you'd still have 2, 2, 2, and 2. On the outside, we already have a negative 3. We'll bring that down. We ask if there's any pairs. There are a pair of 2s, so we'll put those there. There's another pair of 2s here, so we'll put those there. If there's anything left over, we'll put it on the inside. There's a 5, so we'll put it right there. We multiply. Negative 3 times 2 is negative 6, times 2 is negative 12, so our answer is negative 12 times the square root of 5. If there's ever any questions, you guys can always raise your hand, and hopefully your substitute will see and be able to push pause. Otherwise, if you have any questions, maybe just circle the number, and you can ask your neighbor as you are working on your assignment. Number 4, we can break this down into the square root of 45 divided by the square root of 64. We all know that the square root of 49 is 7, and the square root of 64 is 8, and this would be our answer, 7/8. If we could simplify that any further, fraction any further, we would. Like if we had 2/8, we would simplify this down to 1/4. That's not the case for this problem itself, but we would simplify any fractions that we might have. Number 5, we can break this into the square root of 3 over the square root of 100. You can't simplify the square root of 3. The square root of 100, though, is 10, and this becomes our final answer. Number 6, 72 breaks down into 36 and 2. 36 is 6 and 6. 6 becomes 2 and 3 and 2. On the outside, we have a 2. We ask if there's any pairs. There's a pair of 3s, so that can go outside. There's a pair of 2s, so that can go outside. And I'm left with a 2 on the inside. 2 times 3 is 6, times 2 is 12, times the square root of 2. What was our final answer? Our next directions say perform the indicated operation for the radical. Do not give a decimal answer. This means we need the exact answer. All answers should be in simplest radical form. That means no decimals. This is the exact, fully simplified. That means even if you have a -1, you'll end up with just a negative. If you have something times 1, you would just have your answer. For this part, what we do is we would multiply the radicands together. So we would have the square root of 6. If we could simplify the square root of 6 anymore, we would. But that's as simple as this gets, is just there. For number 8, if there's numbers on the outside, we'll multiply those two together. So that's 15. We'll multiply the radicands together. 6 times 2 is 12. We're not done yet. We need to break down 12, which is 4 and 3, or 2 and 2. We ask if there's any pairs. There's a pair of 2s. So on the outside, I have 15 times my pair, and whatever's left over is my 3. 15 times 2 is 30, times the square root of 3. For number 9, if we're squaring this, what we do is we square the number on the outside, and we square the number on the inside. So 7 squared is 49, and the square root of 3, the 3 squared is 9. We each know that the square root of 9 is 3, so we really have 49 times 3. 49 times 3 is 147. That would be a pretty tricky problem to have on your test on Monday, or on Tuesday. But if you needed to, you could always write this down and say, hey, that's 49 times 3. 3 times 9 is 7, carry the 2. 3 times 4 is 12, plus the 2 will give us 147. So if you ever do run into some problems, you can always multiply using the long way without your calculators. Remember, your test tomorrow does not have calculators on it. You cannot use calculators. Number 10, written in a slightly different way, but we use the same method. This is 4 times 3, which is 12. We'll multiply 48 and 12 together, and we'll get 576. If you're really smart, you could either use 48 and 12 here, or you could realize that 576 actually breaks down into 24 times 24. It is a perfect square. I didn't have you memorize all the way to 24. That would be a lot. So instead, we'll just break these down. We'll say this is 8 and 3. 8 is 4 and 2. This is 2 and 2. Again, this would be 3, maybe 8. This could be 2 and 4. 4 is 2 and 2. I have a 12 on the outside that's already here. I'll ask if there's any pairs. There's a pair of 2s, so I'll say times 2. There's a pair of 2s right here, so I'll say times 2. There's a pair of 2s right here, so I'll say 2. And there's a pair of 3s right here, so I'll say times 3. There's nothing left on the inside. There's nothing left on the inside, so I don't have to write anything with my radical. All I have to do now is just multiply these numbers on the outside. 12 times 2 is 24, times 2 is 48, times 2 is 96, times 3 gives us 288. Another way to do this problem, if you recognize that this was 24 right away, you could simply say 12 when you pull out a 24, because there's a pair of them. You could say times 24, and that would give you 288. Again, these are really big numbers for you to work with. I understand that. My goal is really that you guys can break things down, which looks a lot like this, which I'm confident that you guys can, that you know how to divide 24. Number 11 looks good. It's a good problem. What we'll do is we'll start off, we'll multiply these together. This isn't hugely crucial, but it's 768. And we'll break these down. This would be 24 and 32. Pretty easy to break those down because it gave us 24 and 32 to begin with. 24 again is 3 times 8. 8 is 4 times 2, which is 2 times 2 again. 32 we could say is 16 and 2. 16 is 4 and 4. And then we have a whole bunch of 2's here on the bottom to end up with. We'll ask if there's any pairs, and I'll start out here on the right side. There's a pair of 2's. Here's a pair of 2's. Here's a pair of 2's, even though that one's up a little higher. And here's a pair of 2's. And at that point, I look here, and there's a 3 left over, so I'll stay on the inside of the radical. I'll multiply these together. 2 times 2 is 4, times 2 is 8, times 2 is 16, so I have 16 times the square root of 3. Number 12, we're squaring, so we'll say 9 squared is 81. The square root of 3 squared is the square root of 9. The square root of 9 is 3, so I really have 81 times 3. 8 times 3 is 24. 1 times 3 is 3. So my answer is 243. We're on the back side now, so please turn it over. It says perform the indicated operation for the radical. Do not give a decimal answer. Again, this means that we need the exact answer. All answers should be in simplest radical form. When we add things together, we need to check to make sure that the radicands are the same. So if they are, which they are here, we have the square root of 5 is the same. We basically just add the 3 and the 7 together to get 10 times the square root of 5. Number 14 is going to be a little bit more work because we need to break these down. And then again, if they are exactly the same, then we'll be able to continue from there. This becomes 8 and 3, which is 4 and 2, 2 and 2. This would say we have a 6 on the outside. If there's any pairs, there's a pair of 2's. So we'll say times 2. See what's left over. We have a 2 left over as well as a 3 left over, so we'll leave those there. This would be a 12 times the square root of 6 right there. The 48 breaks down into maybe 16 and 3. This could be 4 and 4, or 2, 2, 2, and 2. You ask if there's any pairs. There's a pair of 2's. There's a second pair of 2's. And there's a 3 left over. So this would give me plus 4 times the square root of 3. I look at this and I notice that the radicand here is a 6. The radicand here is a 3. I can't combine those in any way possible. So this is my final answer. This will happen from time to time. Don't be alarmed, but you might go through and check your work just to make sure that you did everything correctly. It's not a bad idea. 15 breaks down into 4 and 11. 4 is 2 and 2. This would give me a pair of 2's, so I have 2 times the square root of 11. 99 breaks down into 9 and 11. 9's a perfect square, so it's 3 and 3. I have a pair of 3's with a square root of 11. There was a minus sign up top, so I need to make sure there's a minus sign down here. And at that point, since the radicands are the same, they're both the square root of 11, I'm going to end with a square root of 11. And all I do is I say, what's 2 minus 3 is actually negative 1. And remember, I don't write negative 1. I'll just leave this as negative square root of 11. This is the most simplified form and the only way that answer would be right. Our last two problems here, a little bit different than what we've been doing. We break 52 down. This would be 13 and 4. 4 gets broken down into 2 and 2. We ask if there's any pairs. There's a pair of 2's with a square root of 13. There is a minus sign here, so I'm going to write it so it looks like a negative 2. I'll bring this part down. This will just be 15 times the square root of 13. I notice that my square root of 13s are the same, so my radicands are the same. I can add these together or subtract them. So I'll just say 15 minus 2 is 13 times the square root of 13. My last problem, number 17, if you notice, there's a whole number here, there's a whole number here. I'll simply add those together. I'm going to tuck this away at the very bottom. I have 20, and that way I can kind of concentrate on these other two things, which will seem a little bit more important. The square root of 28 could be 4 and 7. 4 gets broken down into 2 and 2. I have a 5 already on the outside, and I'll multiply that by a pair of 2's. What's left over is my lonely 7. This will give me 10 times the square root of 7. On this side, we have 63, which is 9 and 7. 9 is 3 and 3. We already have what looks like a negative 4 on the outside. We have a pair of 3's, which would move to the outside, and I have a lonely 7. So it'd say minus 12 times the square root of 7. At this point, we look and we say we have 10 minus 12, which is negative 2, times the square root of 7. These are the problems that I want you to look at. Several of these were from your in-class notes, or they're from assignments. I kind of took them. I wanted you to go over these. In case you don't still have all your notes or whatever, you can always go out to the blog. I would concentrate on these 3 days. This was Wednesday, Thursday, Friday of this past week. If you click on any of these handouts right here, this would give you not only the notes, but also the homework that you could go over these again. And if you want to, you can always watch the videos in which we did the notes in class. This little piece right here will actually be the video that you're watching right now. So if you want to watch this over again, you can. And this right here is going to be your homework. It says review again, radical expressions. It'll be this handout if you need it. What you're writing on right now is this in-class review right there. So again, the blog has a lot of important information on it. I do want you guys to be ready for this test. I do think you guys are going to be. You put in a lot of work last week. I just want to make sure that you guys aren't short-sighting yourself and making small mistakes when we realize, hey, Thanksgiving's getting close. We need to concentrate just a little bit longer so that we can relax over this nice long break. I would be happy if you guys do very well on this quiz. I know that my dog would be very happy too, so make sure that you guys do well for my dog. Here he is. Here's Baloo. He says hi. He's very excited that you guys are here watching him. He's right there smiling at you guys. I hope you guys do well on your quiz tomorrow. If you need some help, come talk to me tomorrow. Your sub is now going to stop this recording. She's going to pass out your assignments that will be due tomorrow. You may work by yourself or with one other person on this, but I do need you guys to stay in your seats. Please stay in your seats and work on this assignment, and you guys have until the bell rings in order to work on this in class.